Welcome to NCERT Solution Math. In this video we are going to discuss about very important topic in mathematics, okay, which is complex number. Okay, before we begin this topic, I would like to ask some question. First of all, what is the solution of this quadratic equation? X square minus 4 equal to 0. We all know that solution would be what? X equal to 4, x equal to plus or minus 2, isn't it? So now if I say what is the solution of this quadratic equation, many of you may not know. Okay, yes or no? So you try it like this: x square equal to minus 1, then you would be stop here, you cannot solve anymore. So basically there is no any real number. If we square that, we'll get a negative number, isn't it? So basically what I'm saying is square of any real number is non-negative. If we square any real number, suppose take 2 square equal to 4. Will you ever got a negative number if we square a real number? No. So here we stuck. So to overcome this, to find the solution of this kind of quadratic equation, we introduce our complex number. So there was a requirement to extend the real number to some large system, so that is called complex number. So we introduced a symbol which is called iota, which is basically written like this, which is equal to root over of minus 1. So iota square equal to minus 1. Okay, so if we put this value over here, x is square minus 1, x equal to what? Minus 1 over root over of minus 1 equal to I, isn't it? So it will be plus or minus I. So this is the solution of this quadratic equation. So let me remind you one thing. When we were in your earlier classes, when we used to study quadratic equation, x square plus bx plus c equal to 0, we used to follow a formula which is Sridharacharya, where the roots were alpha and beta equal to minus b plus or minus b square minus 4ac by 2a. So for discriminant d equal to b square minus 4ac. Okay, b square minus 4ac. So where d equal to greater than 0, we are getting 2 real root and 1 equal. D equal to 0, real roots and equal. If d less than 0, what we are doing? We are skipping this case. So this is the case we are going to discuss in this class. Okay. So now complex number, basically complex number is denoted by z, which is equal to a plus ib, where a is the real part, b is imaginary part. Okay, we can write like re of z equal to a, imaginary of z equal to b. Let me give you an example so that it will be clear to you. Z equal to 2 minus 3i. What is real part of z over here? Re of z equal to 2 and z equal to minus 3. Basically we were taking the coefficient of I is imaginary part, okay, this one, and this is real part. Now when we will say two complex number, suppose z1 and z2 are equal, if z1 equal to a plus ib, z2 equal to c plus id, these two will be equal if and only if a equal to c, b equal to d. Okay, this is the condition, it must follow to be equal. Got it? I hope everything is clear to you. Now what is now power of I? Power of iota, okay. Iota equal to minus 1 root over of minus 1, iota square equal to minus 1, okay. Iota q equal to what? Minus 1 into iota equal to minus 1, this one, into iota, another iota, okay. So minus iota, iota 4 equal to, if we square this iota square, it will be 1. So basically if we have more power like iota 340, how to find this thing? Just divide by 4, okay. 344, 832, 205, 0, okay. So we can write this one as iota 84 4, okay. So now we can write this one as 1 because it is multiple of iota 4, it is multiple of 4, so it will be 1. Now similarly the standard form is iota 4k plus equal to 1, iota 4k plus 1 equal to root over minus 1. Or iota, okay. Iota 4k plus 2 equal to minus 1, 4k plus 3 equal to minus iota. So this was all about power of I. Now let's move to another thing. Remember one thing, if we have two non-negative number, suppose minus 1 and minus 2, okay, root over of minus 2. If we multiply these two, minus 1 into minus 2, minus 1 into root over minus 1 into root over minus 2, it would be what? Do you know? We cannot find this kind of thing. or it won't be equal to root over of minus 1 into minus b. Okay, minus 1 into minus 2. This case is only valid a into b root over of a into ab is valid only if these two are what, positive or positive negative or negative positive. Okay, and it doesn't equal to this thing if a and b are negative real number. So now let's discuss about complex conjugate. Suppose we have complex number z equal to a plus ib. Complex conjugate is basically you have to put a negative in between them. Okay, so complex conjugate is basically written as z bar, which is equal to a minus ib. Okay, if it were negative, then it will be positive. If it is positive, then that would be negative. I hope everything clear. Okay, now mod of z or modulus of z, which is denoted as like this, and which is equal to root over of a square plus b square, which is non-negative real number. Okay, so this is modulus of z. Now let's understand by an example. Z equal to 3 plus iota, then modulus of z equal to 9 plus 1. Okay, 10 root over of 10. This is the modulus of this thing.